Hey, it's Alien Machine AI here, back with another video. This time we're going to use the pose data. Last time I showed you how to extract pose data, and we made a workflow for ComfyUI from scratch for extracting pose data from any image, in particular uh, human subjects. I also made a video about canny ControlNet, and we are going to do a similar video now. We are going to set up for a pose data control net, and we will use the pose data using the OpenPose model for SDXL, as found once again on Civid AI Guide to ControlNet Part 1 Basics. You can find all the models compiled in a big list, which will link you. We want ControlNet, Tenant Arc, T2I, OpenPose. Let's see. You could also try other types. I've tried Tenant Arc. We tried Tenant Arc in the last video and it worked. So choose the SDXL model for OpenPose. This is this the T2I adapter? Or is this? Ah, I see. This is the T2I adapter, and this should be the control net. So we'll try ControlNet Koya OpenPose V2. And either way, I think. Let's see. OpenPose Anime. Huh. Here we go. Tenant Arc OpenPose is what I was looking for in the list. Either way, you load the T2I adapter or the other type in the same node. They work almost the same. T2I adapter is more efficient, people say, but with depth or canny, I like to use the full strength model. It takes longer. I think I got better results using that. So we need to take this model, whatever model for ControlNet that you want to work with, is pre-processed with a different node. Let me find my install for the models directory, ControlNet directory. I put an SDXL directory there myself. Here you can see the canny, and we're pasting in OpenPose dot safe tensors ControlNet model. And we need to get the Comfy. Where'd Comfy go? It's in my panel here. We have the workflow from my last video with Canny. This was the canny result, but we are going to start a new workflow entirely. Here we are with the blank Comfy workflow. What do we want to do today? We want to use pose data and control nets. We want to feed the pose data into a control net, which will modify the conditioning using the control net model. It's an additional neural network, I believe, that modifies the conditioning in the node. Apply advanced control net, which takes inputs here, positive and negative conditioning, the control net model, which will use the load advanced control net model node, link it up, select the right node. Well, we need to refresh this page because after you get the model into the SDXL ControlNet directory shown here in the ComfyUI models directory, I had to restart ComfyUI, refresh the page, and it's now showing up with OpenPose model in this load advanced ControlNet model node. And what we want to do is give this the image, and what we're going to do is use a preprocessor so that we can extract the data from an image we give it directly in this same workflow. Otherwise, you don't have to have the pose data already extracted. If you already have data extracted using the method in the last video, you can just load the image directly, I believe, without having the preprocessor in node in between. We're going to have a load image. We're going to have a DW pose estimator node. Thanks to that developer. This I want at 1024 resolution. I went over this all in the last video, in essence. And we are going to have the rest of the workflow still. I think I lost the other workflow. I would have copy and pasted it over. This is better to have the full explanation for you guys. So we have the image, the preprocessor from the ComfyUI ControlNet auxiliary preprocessors pack of nodes. We have the OpenPose ControlNet, and what it needs next is the conditioning. We're going to use SDXL, so we want SDXL clip text encode. SDXL is best for SDXL. If you work these extra variables properly, as I have already explained in the last video. And we're going to use the load checkpoint node. The clip worked. That was baked in Albedo Base Excel last time. We have the model here. We're going to give to this VAE. VAE is baked. You need to next have a sampler. We will use K-sampler efficient. What's going on there? Oh, okay. It's a good time to save my workflow. Don't forget to also export your workflows, not just save. You want them fully exported. I hope this is working. Let's refresh. Okay, it's working in this. Okay. Now we have the sampler. This is positive, this is negative. Now we're going to just give the latent this dimension. If you're going to give the latent a different dimension, we need to change this and change this. And you want to use the JPS resolution generator as shown in my last video. Right now, let's finish hooking up this sampler. This is the right model, right? It's this, my OpenPose. The right workflow. I'm getting confused because it refreshed and it's not working on the other page anyway. K-sampler efficient takes the model. It'll take the modified conditioning from the control, apply advanced control, that node, which is taking the input image, it's taking the conditioning, and it's modifying the conditioning before it hits the sampler, which gives a final image based on those things. The last thing this workflow needs is the latent image, empty latent image, doing the same thing as before. We're going to do convert width to input, convert height to input, use the resolution tool for SDXL. SDXL resolution is JPS. Hook up the nodes, and there we are. You can do different resolutions, and it will still be a tangible image using this method. You need to hook up the nodes for the latent image, and once again have a preview image node and the save node. Will show image save node by WAS. And I don't know, you guys gonna bet will it run? Let's see. One last look at this. We didn't look at the settings for this. VAE decode you can set to true tile if you prefer. Denoise it. Euler ancestral is known to give like a softer look that some people prefer, supposedly. Let's run the workflow. Let's see if it will work. We didn't give it a prompt. Maybe that would help. No, we didn't give it a good pose either. Let's give it a good. Here I've set a better image. For the pose, we are going to attempt this ballet image pose and see what happens with the prompt. In the image, a woman is flying through outer space with the galaxy seen behind the subject in the foreground. And you can experiment with different prompts in these two encoder boxes. We'll just leave this as air. The image is an air. Okay. Let's see if this helps us. Let's double check. Why else would this not work? Oh, let's see. Oh, oop. See, oh, I love stable diffusion. Look at this. It's gonna work. Yes. Well, did you think I was joking? It's working exactly. It's using the exact pose. This is what I was hoping for with my Zoe locally pose workflow video where it was not doing this. This is what I was saying ControlNets can do, which was not being done with the pose in their technology. As I said, if it's different technology, you can't expect it to work the same. This is cooler in a way to have the pose you want. In particular, their other tool that the workflow, which was complex to install, honestly. But if you want to use someone's workflow without being able to modify it and integrate multiple technologies, that Zoe workflow was generating very nice stylized images for me right off the bat, which I prefer being able to work and tweak and integrate multiple things like this. So maybe we'll look at, in addition to other ControlNet types like depth. I already covered Canny in another video to begin. This was number 2 of ControlNet videos, the pose. And we are going to integrate multiple control nets so you can see what happens if you chain the conditioning here into a different control net and have multiple control nets. Okay? So stay tuned for that. I know you want to.